I hope to get at least to the point where I got with the class this morning. Whatever I don't finish today, I will continue on Thursday. So I will get through all of the formal review. And then after that, then on Thursday we'll do the fun activity, which will help on the final, and then it'll also determine who wins the awesome swag that I brought in, right? And it also, well, it's either going to be a really awesome day or a really terrible day for Xavier, all right? Which I know it won't be in the middle anywhere. It'll be one of the extremes. You're going to be somewhere.
No, you know what though? I was really thinking about it during the test. Cause I was really thinking about it. And I'm not really having fun with the fun activities because every time my team wins, the margin of victory is always large. It's never close. And, I like winning.
This is the worst trash talking
I
I've
like
ever
winning.
heard.
I
Go
like
ahead.
winning. I don't like beating. I don't like winning and in a blowout. I like close games. I like winning because that way I can say like, see, you're better. You just weren't better than me. See what I'm saying? Like,
He's had his trying
You went bang like 8 times last year. Like, great.
All right, well,
You quadruple bang.
again, I think that's what, goes as trash talk in this room. I think that's what that was, so take it for what it is. I'm gonna go through the review. I've got good news and bad news. Well, the good news is that for one of the questions on the exam that you just took, I decided to accept 2 possible correct answers. It had to do with angiotensin 2 and the effects of angiotensin 2, and what does it do to it said something like, let me just read
That
it.
was kind of confusing.
Hold on.
Imagine I did.
Hold on. Where is this question 7?
It's hard to me.
Hold on. There's going to be some bad news. Just remember, this is the good news. So this is the question. Which of the following is not a way angiotensin 2 affects the kidneys? And it says it stimulates the release of aldosterone. It enhances reabsorption of certain ions. It increases GFR. It can decrease GFR. And then E, actually, all of the above are ways that angiotensin 2 affects the kidneys. So the correct answer I was looking for was it can decrease the GFR, okay? That's the answer I wanted, okay? However, somebody in the class this morning got on the internet and was point grubbing and found some little detail on, I don't know anything about science.com, and found this little detail that said that it can also increase the GFR. So I decided to accept either it can decrease the GFR or actually all of the above are ways that angio 2. So I accepted 2 answers. That's the good news.
What letter?
The bad news. So if you had version 1, if you had version
2?
Wait a second, hold on. Did I mess this up? So on version 1, if you chose either it increases GFR or if you chose E, then I would have accepted. So it was C or E for version 1. If it was version 2, it actually was D or E, okay? Here's the bad news. The bad news is, except for Marie, no one in the class made that mistake, so it just doesn't apply to you. I'm sorry. That was a big speech for that much people. Marie, I hope you're excited.
We went through all this really fast.
What's that?
We found that out fast.
Well, this kid, this guy, this morning, he started point grubbing as soon as he got out of here, and he sent me an email, and I had to look back, and I was already like, oh, that's nonsense, just because that's what I usually say, but then I decided, all right, I'll look into it. So, anyway, all right.
He sent you the article? He sent you the article where it's...
No, he didn't send me the article, but he just said he did an internet search, and then I started looking around the internet, and there was some reliable sources that said that some cases angiotensin 2 can increase the GFR, in some cases it can decrease it. So I decided to accept 2 answers. Yeah. All right, so enough said. Let me get on with the actual thing here and help you guys out with this stuff. So, endocrine. Yeah, there's a lot of that.
Shut it off.
Hold on. All right, so a couple of things. Let me just tell you what to expect first with the format. So it's 150 questions. Most of the questions are matching. There's 102 matching questions. 33 true false, and 15 sequence. There are no multiple choice, which I know you guys are used to.
What?
Which,
What?
there are no multiple choice.
No.
I know, is that okay?
Well, yeah, I kind of blanked out.
Wait, what? Wait, you took,
Did I mess up something? Did I say something wrong?
Yeah.
There are no multiple choice. There's 102 matching, 33 true false, and 15 sequence. So that's actually good news, kind of in a way, because when you have multiple choice, which you guys are used to, there's a lot of reading. There's a lot of reading when you have multiple choice. With matching, there's not nearly as much reading, okay? Also, too, the other thing with matching is sometimes if you pay attention like to the directions at the section, it'll say the choices can only be used once. And then you can use it to your advantage to kind of do process of elimination,
But
okay?
there's gonna be some where they can be used multiple times.
Yeah, so
Those are the
So
worst.
wait a second. So pay attention though on the map. The matching sections are divided into different areas, okay? Some of the matching sections will say the answers are only used once. But a lot of the sections will say they can be used once, more than once, or not at all. So just read the directions carefully. Yes?
Can we write on the final exam?
No.
No,
No writing on the final exam.
please.
I could give you an extra sheet if you want to, but I can't let you write on the final exam.
You're breaking my heart.
Sorry. Yes. So that was the other thing I wanted to bring up. You get the full class period for the final. So time is usually not an issue. I mean, I know there are some of you that like to wait till the last minute, but most students will finish with like an hour left, okay? So I wouldn't worry so much about the time. I'll give you reminders. You know, I'll remind you when you have an hour left. Probably a lot of you will be gone by then. So I wouldn't worry too much about the time. What else to tell you? Sequence questions, those are where you have to put things in chronological order. What happened first, what happened second, what happened third. You may remember that from the A&P one, but in case you guys don't remember, so the way it kind of works is, let's suppose questions 45 through 50, suppose that was the sequence section on the exam. What they would then do is next to the number 45, they'd say something like first event or first thing that happens, or they might just use the word first, and then the next 46 would say second, third, it's blah, 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 blah. So you'd have all those things there on the left side, and then on the right, you'd have the different things that you'd have to put in order. So if you thought that, say, choice E happened first, for 45, you'd put an E down, right? If you thought that B happened second, for 46, you'd put a B down. Now, one thing I want to tell you, just to remind you, you probably remember this, but just to refresh your memory, because the Scantron is limited to 5 letters only, right, A, B, C, D, and E, when you have matching sections, sometimes they have more than 5 choices, and the way that they get around that limitation is by doubling up on letters, okay? So, you know, if you wanted to put this choice as the third event on that line, you would color in both the A and the B in order to choose that, for example. That holds true for all of the matching sections, not just for the sequence sections. Anytime they have more than 5 choices, they'll start doubling up in letters. I think you'd understand it once you see it, but I just, you know, if I can tell you what to expect, it'll alleviate some of the trepidation and you won't be as fearful. At least that's my goal. All right. Any questions about any of that stuff? All right, so let me run through this stuff. You can see the breakdown here. I told you it was not equal. You know, go figure, right? I mean, the digestive PowerPoint, that was one of the biggest PowerPoints that we had, and it has the fewest number of questions, right? Endocrine, as I promised, there's a lot. There's a fair amount, that was the blood vessels in hemodynamics, there's a fair amount of that as well. So I'm gonna go through the review here. I'm gonna go in order that we actually covered these chapters in class, because I think that helps to trigger your memory if you go kind of in order. So I'll start with 18, but then I'll jump down to 28 and 29. Then I'll go back and cover 19, 20. I'll kind of stay in order, right, until I get to 24. And then after 24, I'll temporarily skip 25. I'll do 26, I'll do 27, and then the last thing I'll do is 25, okay? That's the order. Now, I'm not gonna get through nearly all of that today. If it happens like it happened this morning, I think I'll get as far as probably the heart. That's where I stopped this morning. Yeah, there's a lot to cover. Any questions about bringing number 2 pencil, all that jazz, bringing an eraser, everything like that? Any questions about the setup or anything along those lines? Oh, the other thing I want to remind you about Everyone see my email about the tutoring center having that review session deal that's going on? Okay. I guess that's Monday from 3 to 4. Does that sound right for you guys that are affiliated there? And it appears that they're going to be doing it in the form of a Jeopardy game. Is that, yeah, I wonder where they got that idea from.
That's why we signed up.
Anyway, all right.
What is the fun activity, Jeopardy?
It is, yeah. Fun activity, spoiler alert, fun activities
Oh
Jeopardy.
my god! Oh my god! That's how you bet. That's how you won last time because we blew them out in the first round, and then the second round they get that little
Get
like,
over
little
it.
question. And
Oh, you-
you bailed them out.
I just built it up by telling you that?
No. Well, yeah, no, you bail out whoever loses because like you still have a chance at the end of the game.
He's not playing.
They do kind of have a chance. You're right, you're right. I'm sorry, I didn't know you'd be triggered by that. All right. Anyway, so let me go through this before I run out of time. So first of all, starting with the endocrine system then, it says, and I'm just going through the final exam study guide that was on Blackboard, so if you have that, you can follow along. If you don't, you can print it out tonight and see where I get it. So it says, oh, sorry, one more thing. Sorry, I keep wanting to start, but I keep forgetting. Also, don't forget, I think you guys all know this, but if you manage to score higher on the final exam than on one of your 4 lecture exams, I will replace your lowest lecture exam score with what you get on the final. So let's just say hypothetically, I don't know, this exam you took today, maybe that was your worst, all right? It could potentially not even matter if you do well on the final, okay? And just historically, I would say probably 75 to 80% of the class will end up replacing it, okay? The final is not impossible. Don't psych yourself out. Oh my God, it's the final. Don't go into, don't have a meltdown and, activate your stress response or whatever, But, yeah, so just be aware of that. Okay, chapter 18, endocrine system. Describe the hormones in terms of their target site of synthesis, site of release. That's covered below. Also, the next thing it says, describe the functions of each hormone. That's also covered below. I don't know who exactly wrote this thing. I'd love to revise this because there's a lot of redundancy, but anyway. Matching category with target choices. So this is going to be a matching section, and those are basically going to be the choices that you have. Osteoclasts or osteoblasts, principal cells of the nephron, smooth muscle, interstitial cells of the testes, corpus luteum, and you're going to have to pick which hormones target those particular items that are listed there. So let's just go through this. So first of all, osteoclasts or osteoblasts. Anyone remember a hormone that targets the osteoclasts or osteoblasts? Yes? Corey, I saw your hand up. Parathyroid hormone is exactly correct, Corey. Thank you for your politeness. Anyone else? Go ahead, just blurt it out. Or maybe you don't have an answer now. There are other answers besides parathyroid hormone.
Calcitonin.
Calcitonin, thank you. Calcitonin also targets it. And then there's also one more to be aware of. Anyone know the other one? Yes? Calcitriol. You were doing so well, Corey, but no, it's not calcitriol.
Is it EPO?
No. What's the hormone that, I'll try not to give it away, what's the hormone that makes you get bigger?
HGH.
Human growth hormone also targets the osteoblasts to help you grow. All right, so PTH, calcitonin, HGH, they all target either the osteoclasts or the osteoblasts. The next possible target is the principal cells of the nephron. Here they're talking about, the cells that make, those special cells that we talked about that make up like the collecting duct and the distal convoluted tubule. What were some of the hormones that targeted those areas? ADH does, certainly, right? What else?
Aldosterone.
Aldosterone does, good. And then one more.
Is it ADP?
No? Also, PTH does, parathyroid hormone, because it targets the distal convoluted tubule and promotes calcium reabsorption. Okay? All right. Smooth muscle. This one might be a little bit tricky because there's a lot of hormones that target smooth muscle, but you may not think of it in that level of detail, so you might not occur to you off the top of your head. Can anyone name a hormone that targets smooth muscle?
Cortisol, oxytocin.
What'd you say, cortisol?
Yeah. No.
Um,
Epinephrine.
Okay, epinephrine's a good one. Epinephrine,
Oxytocin.
norepinephrine, they target like smooth muscle that's like in the walls of your blood vessels and cause vasoconstriction. You also mentioned oxytocin, that's a good one. Why does oxytocin target smooth muscle?
Childbirth.
Yeah, so it's targeting the wall of the uterus, which is smooth muscle. It's also targeting little smooth muscle cells that are in the breast tissue to promote the milk ejection, right? So epinephrine, norepinephrine, oxytocin, and then I don't think anybody said the other one yet.
Relaxing?
ADH, thank you. What's the other name for ADH? And then what's the other name? There's still one more name. Vasopressin, right? And that it got that name because of the vasoconstriction that it does. So it's targeting smooth muscle in the walls of your blood vessels, all right? So all of those guys are good examples of targeters of smooth muscle. Interstitial cells of the testes. So first of all, I may have used that term in class. I don't know if I did or not, but there's also probably a more famous name that the interstitial cells of the testes are known by. What's that?
Sertoli?
Other one.
I don't know.
Anyone know? Starts with an L.
Luteum.
Rhymes with Leydig cells.
Leydig.
Leydig cells, or Leydig cells, right? Remember Leydig, okay? So what targets the Leydig cells? Anyone remember? I'll give you a little hint. It's the same hormone that causes ovulation in women. No, no one's gotten it. It's a surge in that, yes?
Is it Lutein?
No, it's not that. I
Oh,
think you
a
said it.
surge?
Why do I feel like I'm playing charades? Yeah, what?
LH.
LH, you got it, It's LH. Yeah, please, don't go any further.
Luteinizing hormone.
Yes, and that is what the abbreviation stands for. Thank you. That is right. By the way, that actually reminds me. There are a ton of abbreviations on this practical, more so than on the A&P1. On this final exam, way more than on the A&P1 final exam. So feel free to come up and ask me what they stand for if you need to. Personally, though, if I were you when I'm studying, and you see these abbreviations, say them to yourself, or just say it in your mind. Like, remind yourself constantly what these things stand for, because it will help, okay? All right, last thing is corpus luteum. What hormones target the corpus luteum? Well, what's the hormone that creates the corpus luteum in the first place?
LH.
LH, all right? LH triggers ovulation, and then LH, when the follicle ruptures and releases the oocyte, it turns into the corpus luteum, and then LH kind of keeps the corpus luteum alive for the last 2 weeks of the menstrual cycle. What's the other one that targets the corpus luteum in pregnant women? If you get pregnant, what keeps the corpus luteum alive?
Progesterone?
No, the corpus luteum makes progesterone, but what targets the corpus luteum to keep it alive? You want to remember? I'll give you another hint. It's the same one that you test for with the urine dipstick to see if you're
Oh,
pregnant.
HCG.
HCG, okay? Human chorionic gonadotropin targets the corpus luteum in a pregnant woman. LH targets it in, non-pregnant women during the menstrual cycle. All right, next section, it says matching category to match the hormone to its site of synthesis. So the site of synthesis is where the hormone is made. That's different from, or it may be different from where it's secreted or where it's released, okay? Where it's synthesized is where it's made. Where it's released or where it's secreted refers to where it's actually put into the blood. Most of the time, where it's made and where it's secreted are going to be the same place. But there are some tricky exceptions to be aware of. So let's go through some endocrine glands, and you tell me the hormones that are synthesized there, all right? So starting with the hypothalamus. What hormones are synthesized in the hypothalamus? No. So, wait, yes. Yes. So, yes, this is exactly what I wanted to say. Right, I'm sorry I'm acting surprised that you got it right. Yeah.
Toxin, but it's made in the hypothalamus, and the other one, the interior, needs to get direction from the hypothalamus.
Yep, you're right. You're right about all that. So, oxytocin and ADH are quote-unquote posterior pituitary hormones. But remember, they're actually made in the hypothalamus. They're synthesized in the hypothalamus, and then you have these neurons with these axons that basically carry the material down to the end of the axon, which is sitting in the posterior pituitary, and that's where it's going to be released into the blood. So those are the two exceptions that I wanted to point out. Oxytocin and ADH, synthesized in the hypothalamus, but actually released in the posterior pituitary. What else, though, is made in the hypothalamus? And I think you were on the right track. How does the hypothalamus communicate with the anterior pituitary? Using what?
Something for
Hypophysial cortical
Yes, yes, but what's being put into that?
hormone.
What are those hormones called?
Hypothalamic.
Yeah, they're hypothalamic releasing hormones or hypothalamic inhibiting hormones. So that's the other guys that are made in the hypothalamus. All right, let's talk about the pituitary then. What's made in the anterior, what are the, and there's 7 of them, what are the 7 hormones that are made in the anterior pituitary? Okay, HGH, TSH, FSH, LH,
Wait, these are the anterior pituitary?
uh-huh. Prolactin, that's a good one. Yep, what else? MSH, melanocyte stimulating hormone. Did we hit everything? Did you
So
do?
is it everything that's in that column?
Pretty much, yeah. It's seven things that are there. Yeah. All right, good. All right, moving our way along. What hormones are synthesized in the thyroid? T3, T4. Don't get that word confused with the correct answer. Calcitonin, right? Calcitonin is made in the thyroid as well. What's made in the parathyroid? Parathyroid hormone, okay. What hormone is made in the heart?
Oh,
Atrial
and-
diuretic peptide. Or-
Atrial natriuretic
Natriuretic.
peptide. Yep. Good. What hormones are made in the stomach? What's that? Gastrin, certainly. What else? Starts with the same letter. Makes you get hungry.
Gastrin.
No, she said gastrin.
Oh wait, no.
You said it. What'd you say? Ghrelin. Ghrelin. Yeah, it's the appetite stimulant. What hormones are made in the testes?
Testosterone, estrogen.
Testosterone. It can be converted into estrogen, but yeah, it's it's primarily the testosterone that's being made there. What's made in the ovaries? Estrogen.
Progesterone.
Progesterone is also made there. Back to the adrenal gland. What's made in the adrenal cortex? Basically, kind of 3 main hormones.
And aldosterone.
So aldosterone, cortisol, your stress hormone, and remember the other part, the zona reticularis made the weak androgens, right? So aldosterone, cortisol, and the weak androgens. By the way, on the final exam, instead of using the word cortisol, they use the word cortisone. Okay, so don't be thrown off. It's the same thing. Don't be thrown off by that. You can come up and ask me again if you forgot, but just point that out. What hormones are synthesized in the adrenal medulla? Epinephrine and norepinephrine. Good. What hormones are synthesized in the pancreas? Insulin, glucagon, somatostatin, pancreatic polypeptide. I know you weren't getting any love into those ones, but they're there too. They're there to haunt you and wreck your world on the final exam. Maybe not. I'm just throwing it out there. We'll see. They might wreck your world. Who knows what's going to happen. All right, the next matching category is to match the hormones to its primary effect. So basically, you're matching the hormone with what it actually does. So let's start with melatonin. What is it? Makes you sleepy, right? It sort of calms you down. What about oxytocin again? So it helps squeeze the baby out, and it also helps, milk ejection or milk letdown. What about T3 and T4?
Metabolism.
What do they do to your metabolism?
Stimulate it.
Yeah, they increase your metabolic rate. What about calcitonin?
Tones down calcium.
Yeah, it tones down blood calcium levels. What about PTH?
It stimulates.
It increases blood calcium levels. Good. What about insulin? What's the main effect of insulin? Reduces blood glucose levels. Okay. Now, on the final exam, just because some snobby person wrote this and they just can't talk in clear English, they don't use the words decreases blood glucose. Instead, they say hypoglycemic effect.
All this.
That means decreasing blood glucose levels. All right, hypoglycemic effect is the same thing. So Insulin has a hypoglycemic effect. By the way, we said it's made in the pancreas. Where specifically is insulin made in the pancreas? Islets and Langerhans. By what cells there? Beta cells. It's made by the I know you feel like it should be made by the alpha. It's made by the beta cells. Now, in addition to putting channels into your body cells to help get the glucose into your body cells, insulin also helps for when you have extra nutrients in your blood and you want to store them up. So what else does insulin promote? What's it called? How do you store glucose in the liver? In what form? Glycogen. What's that process of making glycogen called? Glycogenesis. So insulin increases glycogenesis. Also, unfortunately, one other place that the glucose might get stored if you have too much of it is where? In your adipose tissue. So insulin also promotes lipogenesis, right? And then something that I probably didn't touch on, I think I touched on it at one point briefly early on, but insulin also promotes protein synthesis, okay? So insulin's really like a very strong anabolic hormone. It's causing glycogen formation, it's causing fat formation, it's causing protein formation, all that stuff. What's the antagonistic hormone to insulin? Glucagon. What cells make glucagon in the pancreas? Alpha cells. And what's the main effect of glucagon? To do what? To increase blood sugar levels or blood glucose levels. You can probably guess on the final exam, they have a snobby, they say it has a hyperglycemic effect.
I'm just going next.
I'm sorry. Now, in terms of that, in terms of increasing blood glucose levels, what are the two sort of long G words that glucagon promotes?
Gluconeogenesis.
Gluconeogenesis, right? And then also glycogenolysis. Both of those things help to increase blood glucose levels. Good. All right. The adrenal gland, aldosterone. What's the effect of aldosterone? So it promotes sodium and chloride reabsorption, and then what follows because of osmosis? Water. However, at the same time that it's promoting reabsorption of sodium chloride, what's it causing secretion of? Potassium. It's getting out of your system. Good. Cortisol. What does cortisol do? Or what is it known as? Your stress hormone. And what does it do essentially? What's its main effect as your stress hormone?
Fight or flight,
Well, it's involved in that, but it's making what available?
Gluconeogenesis.
Yeah, it's basically making lots of glucose available through primarily gluconeogenesis, so that you have enough glucose so that you can feed your body cells when you're trying to fight off some stressful situation, right? What's the problem called when you have too much cortisol in your body and you start, what is it? Cushing's, that's right, Cushing's. All right, and then finally, you remember the other thing you have in there is the weak androgens, right? Weak forms of testosterone coming from the adrenal cortex. I mentioned aldosterone. What's the difference between aldosterone and ADH?
Blood volume versus blood concentration.
That's true,
Yeah.
right?
Urine.
So ADH is promoting pure water reabsorption, right? And so that will affect concentrations, whereas aldosterone is moving sodium chloride and water, so that'll change volumes, but not concentration. All right, next it says the ROS system, go through the ROS system, so let's go through the ROS system. What's the problem that the ROS system's trying to fix? Low blood pressure. Who detects the low blood pressure? Juxtaglomerular cells in the afferent arteriole. And how do they respond? By releasing renin, which converts what into what? Angiotensinogen into angiotensin 1. And then angiotensin 1 gets converted into angiotensin 2, where?
At the lungs.
At the lungs, by what? ACE, good. How does the angiotensin 2 directly help to raise your blood pressure? By causing widespread vasoconstriction. Additionally, it also goes to the adrenal gland and causes aldosterone to be released. And how does that help raise blood pressure?
Absorb sodium.
Sodium, chloride, and water reabsorption will increase the blood volume, which increases the blood pressure. All right. All right. Finally, we're on to the blood check. Sorry.
Oh,
No,
man.
I'm going in order that we covered it. So I'm going to skip ahead to 28. So let me do that.
Happy people.
All right, 28 is the reproductive systems. And the first thing it says on the review guide is sequence the events of the ovarian and uterine cycles beginning with menstruation. Okay. Now, the way it's worded on the final exam, it says endometrial ischemia triggers menstruation. That's the way it's worded. Does anyone know what endometrial ischemia means?
The death of the infant.
Anyone know what it
Ye
means?
old English.
It means, ye olde English, no. Ischemia just means low blood flow to a body tissue, like low enough to actually cause like eventually the death of that tissue. So all this is saying is that what causes menstruation to happen is when the little blood vessels that are in the wall of the uterus, they'll constrict towards the end of the previous cycle. That'll reduce the blood flow, no oxygen and nutrients, and that's what causes you to shed the lining of the uterus. Fine. Anyway, after you shed the lining of the uterus, after you have the actual menstruation part of it, what comes next? What do you have to do then? Well, first of all, before I even get there, sorry. When you shed the lining of the uterus, are you you're shedding the endometrium? Are you shedding the entire endometrium?
No.
No, just the what part of it? Stratum functionalis, and then the stratum basalis remains behind, right? So anyway, after you've shed that, what next has to happen in the uterus? You basically got to do what? If you just shed it, then you got to rebuild it. You got to regrow it, right? That's referred to as the proliferation phase of the uterus. That's when you're, basically the cells in the stratum basale are undergoing mitosis to replace the stratum functionalis that was lost, right? So that happens next. As that's happening in the uterus, obviously things are also going on in the ovaries where the follicles are growing. Remember, you go from a primary follicle to a secondary follicle. Oh, hold on, I gotta tell Jonathan that he's got 30 minutes left. Hold on.
Yo, this is good. This is crazy. I don't remember that.
Oh, you mean you are? Oh, okay. All right, yeah. Okay. So, obviously in the uterus, the lining's being rebuilt. That's the proliferative phase. In the ovaries, the follicles are growing from a primary to a secondary till eventually you have a mature follicle. Then somewhere around the middle of the cycle, you should see a surge. I mentioned this kind of before. A surge in what hormone? What actually triggers ovulation?
LH.
A surge in LH will trigger ovulation. The mature follicle releases the oocyte. So that's the ovulation part, right? Now, true or false? The mature follicle that released the egg then just disappears and doesn't do anything.
No, it becomes
False. It becomes the what?
Chorion? No.
The yellow body. Yeah, what's the yellow body?
Yolk sac?
Corpus luteum, right? So after ovulation, the mature follicle that ruptured becomes the corpus luteum, right? All right. The corpus luteum will stay alive for about 2 weeks. As LH comes down from the anterior pituitary, that keeps the corpus luteum alive for about 2 weeks. The corpus luteum turns out high amounts of progesterone, which will keep the lining of the uterus intact for about 2 weeks after ovulation. If you don't become pregnant, the LH levels go down, the corpus luteum dies, and the whole cycle begins again. Okay. Remember, if you do become pregnant, what is the hormone that essentially keeps the corpus luteum alive? HCG. Okay. That's going to come from the developing embryo. There's going to be a layer called the chorion that produces the HCG that'll keep the corpus luteum alive. Remember, the corpus luteum is super important in a pregnancy, at least for the first couple of months, because it puts out high amounts of progesterone that prevent the lining from shedding itself. Okay. Let's see next. The surge of what hormone triggers ovulation? I already covered that. That's LH. What layer is shed at menstruation? Again, it's the endometrium, specifically the stratum functionalis. Next, there's another sequence thing. It says sequence the path of sperm out of the body, beginning with the site of sperm formation. Okay, fine. So, where are sperm formed? You're going to have to be even more specific.
Seminiferous
tubules is where the sperm are formed. Now I'm going to go, just to help you out here, I'm going to go through an excruciating detail through all the little steps. Be aware on the final that they may omit some of these steps, okay? It's okay if they leave out a step. You just have to pick, like, you just got to put what they have in the correct order that they would happen, even if a step here or there is missing, all right? But let me tell you all the steps so you have, like, the full knowledge. So seminiferous tubules, where it's made. Where did the sperm go next? Straight tubules. That then puts them in the middle of the testy. What's that kind of pooling area in the middle of the testy? The reed testis. God, you really know this topic. You're like all over this, Lauren. You're a sperm master. All right. Sorry. All right. So I mean that in the best possible way. Anyway.
Sounds worse.
It sounds way, yeah. All right. Just scratch that. No one's okay, can everyone just delete their phone right now? I still want to come to work in the summer. And, you know, I just. All right. So after the reed testis, where do you go? Efferent ducts, thank you. She's the only one answering though. Everyone else is like crickets, and she knows this. All right. So efferent ducts, and then what's that highly coiled tube that's kind of on top of the testy? Epididymis. What happens at the epididymis tube? Well, first of all, sperm can be stored there, but it's also where they learn how to swim. From the epididymis, you then go into that long pathway, which is the vas deferens, also known as the ductus deferens. Remember, that's going to come around sort of the sides of the bladder. It's going to go up and over the ureters, right? And then it's going to go down kind of the back of the bladder. It's going to meet up with the openings from the seminal vesicles, and then it becomes that short passageway that goes through the prostate called the ejaculatory duct. Then it empties into what? Urethra. What part of the urethra do you have first in the man?
Prostatic.
Prostatic urethra. Then what comes next?
Intermediate.
Intermediate, also known as the membranous urethra, and then the final is the spongy, also known as the penile urethra. All right? That's the full path. They're not going to ask you for the full path. They'll only give you some of those, but make sure you put what they give you in the proper order. Okay? Which hormones prepare the endometrium for implantation? So, what's the hormone that's in charge of causing the endometrium to rebuild itself? Starts with an E, rhymes with estrogen. Estrogen causes the endometrium to rebuild itself. And then it's progesterone that helps to maintain that lining throughout the pregnancy, right? Remember the word progesterone. Pro means like for something, and gest means kind of like pregnancy. So it's like the pro-pregnancy hormone, right? All right, development and inheritance. Matching category with the following choices: amnion, chorion, allantois, yolk sac, placenta, or none of these. That is actually covered in this next section where it says differentiate between the above membranes in terms of anatomy, functions, and what they produce. So these are all different membranes that you'd see like in the embryo or in the fetus. So let me go through each of these in order and just tell you a little bit of detail. So first of all, I realized I didn't tell the class this morning this. Uh-oh. Oh, I'll remember. I'll do it on Thursday.
Tell them to watch
I'll do it on
John's
Thursday.
YouTube video.
What's that?
I said tell him to watch John's
Oh, see, I should tell him to do that. That's right. Okay, so first of all, you should be aware, and this is so stupid, all of those membranes that are listed there, they're present in humans. Duh, we know that, right? But then they're also present in placental mammals. I have no idea why that's listed on there, but
Doesn't that just mean like any creature that's a female?
no, some animals don't have placentas and things like that. It's sort of complicated. Honestly, I don't even remember what's considered a placental mammal. Just know this, for God's sakes, all right? They're present in humans and placental mammals. Fine.
When you have, think of mammals when you have fur and when you don't lay eggs.
No,
No, but
mammals
there
are
are
like
good
when you have
mammals
basically
and
like you can
Oh,
reproduce.
look at that.
All right, you know what? We could talk all day about this, and it would be a lot of fun to argue, but let me just keep going. I'll come back to this later. Amnion, so what you know about the amnion? Well, the amnion forms that thing called the, what? Amniotic sac, right? And inside there's fluid. What's the purpose of kind of that fluid in the amniotic sac? What does that do for the fetus? It can kind of protect it and act like a shock absorber. It also helps to control the body temperature to some extent of the fetus, so it's important for all that stuff. Of the membranes that are listed there, chronologically, it's the first of them to develop, okay? So that's important to know. The chorion. What's the chorion? Or what kind? I mentioned this before. What hormone comes from the chorion? It's all the name's
CVS.
CVS.
Yeah, chronic villi. Oh wait, no, that's not it. Sorry.
Yeah, that's not it. HCG, right? Human chorionic gonadotropin. The name tells you where it's coming from, essentially, right? So HCG, and again, HCG is that hormone that, number one, keeps the corpus luteum alive, at least for the first 3 months of pregnancy. But then number two is also the thing you test for when you're pregnant, like in the urine dipstick thing, okay? So all of that's coming from the chorion. The chorion also, don't forget, is the baby's half of the placenta, right? The placenta is a hybrid organ. Half of it comes from the mom, half of it comes from the baby. The baby's half is the chorion. It's actually those chorionic villi, right? Those finger-like things. So just something to be aware of. Allantois, that helps to form the umbilical cord. Specifically, it contributes to the blood vessels that are in the umbilical cord. How many blood vessels did you have in the umbilical cord? 3. 2 of them were what? What's the correct answer?
Arteries.
2 of them are arteries, and 1 of them is a vein, right? What color were the arteries?
Blue.
They were actually blue, and the vein was red, right? Bless you. All right, fine. That's the allantois. Yolk sac. The yolk sac, obviously we have a yolk sac. It's not as important in us as it is like in birds or whatever, but anyone remember what develops at the yolk sac in humans? It was the first source of our red blood cells, okay? So actually not just red blood cells, but all blood cells are first made in the yolk sac. Before they're made in the red bone marrow, they're made in the yolk sac, number 1. And then also it was an early source of your germ cells. And by germ cells, I mean either your sperm or your egg, okay? Remember, even at that early stage of embryonic life, your body was already starting to think about having its own kids. Mistake, right? Bad. I so wish I could go back and talk to my zygote and tell it like what's going on, right? might rethink things. All right, placenta. So placenta, again, hybrid organ, made up of half of from the baby, half from the mom. Other thing to know about the placenta too, and this happens later on in the pregnancy, is it's also a source of hormones, okay? It becomes the main source of progesterone and estrogens later on in the pregnancy. Remember, the corpus luteum is a big source of progesterone early on, but it'll die off. After it dies off, the progesterone mostly comes from like the placenta. All right, another sequence section, sequence the developmental stages, including the following. Now they're not listed in order, so you gotta put them in order, but the choices are fusion of gametes, bilaminar disc, trilaminar disc, zygote, morula, and blastocyst. So those of you that have the study guide in front of you, or can see that, anyone know which of those things listed should happen first? Would you say zygote? Close, but what has to happen even before the zygote happens? The egg and sperm have to go. So the fusion of the gametes, that means the egg and the sperm coming together. So first is the fusion of the gametes, then you have the zygote, and then of the things listed there, anyone know which thing would happen next? Not bilaminar disc, no. It's the morula, right? So after that, you have the zygote, it'll divide, become 2 cells, 4 cells, 8 cells. Eventually you'll have a solid ball of cells, the morula, right? Remember, the morula doesn't stick around long. It only lasts for maybe 2 days before it hollows itself on the inside and becomes a what? Then it's a blastocyst. Now initially, there's 2 parts of the blastocyst. There's the trophoblast, which is like the outer membrane, and then there's the inner cell mass, okay? That inner cell mass is going to become 2 layers initially. So the next thing that you would have would be the bilaminar disc, right? And that's made up of ectoderm and endoderm. But remember, during like the 3rd week, the mesoderm kind of pushes its way in between the 2 layers. Once you have that, then you now have the trilaminar disc. Okay, so that's the basic order of the things that at least are listed there, right? All right. Moving right along. Let's see here. So now let me go back. And we're on chapter 19, the blood chapter. Differentiate between, matching category the following choices, RBC, basophil, blah, blah, blah. That's covered in the next section, so let me go through that. Differentiate between the types of blood cells in terms of anatomy, divisions, formations, and functions. So first off, red blood cells. What's the shape of a red blood cell? Biconcave disc. What can you say about like what you have inside of the red blood cell? Nothing except lots and lots of hemoglobin, right? No organelles, no nucleus, just lots and lots of hemoglobin. Good. What's the hormone that stimulates red blood cell production? Erythropoietin, which comes from where? Kidneys, right? EPO comes from the kidneys. All right, let's talk about and what's the function, obviously, of your red blood cells? To carry oxygen around your body. All right. Next, you have the white blood cells. What's the function of white blood cells? Basically, body defense, fighting off infections, or possibly being on the lookout for cancer cells, things like that. What's the most common white blood cell? Neutrophils, then lymphocytes, then monocytes. It's okay. Then what? Eosinophils, then basophils, right? Never let monkeys eat bananas. Okay. All right, good enough. Let's see, where was I going with this? Neutrophils are the most common. They're good at phagocytosis, right? Next, you have the monocytes. Now, monocytes are closely related to macrophages. Macrophages are basically monocytes that have left the blood and kind of decided to live the rest of their life out in tissues. They're also good at phagocytosis. Then after that, you have the, sorry, I skipped over the lymphocytes, I shouldn't have. The lymphocytes, remember, are a little bit different than the other white blood cells because they're part of specific or adaptive immunity, right? Remember, you have T cells, you have B cells, there's cytotoxic T cells, there's T helper cells, and then there's the B cells. This stuff kind of comes up later in the lymphatic chapter, but just something to be aware of. Remember, the cytotoxic T cells sort of get up close and destroy infected body cells, for example, whereas how did B cells work? How did they kill things? By producing what? Antibodies, right? B cells work by making antibodies. Now, I will tell you, just to confuse you on the final exam, they don't use the word antibodies in the final exam. They use the word immunoglobulins.
What?
It's the same thing, right? It's just they're using kind of the dumb name for it. Anyone remember the name? What's the name that B lymphocytes become once they start making antibodies? Plasma cells. Okay. All right. So let's see. We did neutrophils, monocytes, lymphocytes, eosinophils. Eosinophils are good against parasitic worm infections. Also, under the microscope, how can you tell an eosinophil under the microscope? Yeah, pink and then headphones. So like kind of pinkish, chunky dots, and then they got this nucleus that looks like sort of headphones or earmuffs. And then finally, the least common are the basophils, right? Basophils promote inflammation. What's the main chemical you should think of when you hear basophils that they release? Histamine. Basophils are also similar to a type of connective tissue cell called a mast cell, okay? I think I mentioned this in passing before. Where are blood cells made in the body? Red bone marrow. All blood cells or just red blood cells? All blood cells and the platelets are made in the red bone marrow. Speaking of platelets, how are platelets formed?
It's when the megakaryocyte bursts.
When the megakaryocyte ruptures. So you have these big cells called megakaryocytes and they rupture and every little piece becomes a platelet. What do platelets do?
Is it viscosity of the blood?
Well, they have some minor impact, but what's the main function of platelets? Yeah, stop blood loss, right? They do hemostasis, right? So they can help stick together and form a platelet plug, which can block off small holes in the blood vessels. They also release chemicals that can trigger coagulation, so they do a lot of things to help with hemostasis. All right, next it says, describe ABO blood types in terms of alleles, antigens, and antibodies. So what are the 4 blood types with the ABO system? A, B, AB, and O. It's all based on what antigen you have on the surface of your red blood cells. So if you have type A blood, you have A antigen on the surface, type B has B, type AB has both, and type O has neither. The other thing though that's kind of weird about the ABO system is what type of antibodies do you find in the plasma, say, if somebody had type A blood? You find anti-B antibodies. So you'll always have antibodies against the antigens that you don't have, okay? Based on that, or because of all that stuff to be considered, which of the 4 blood types is considered the universal donor? O, because you can give their red blood cells to anyone because they don't have any antigens on them. And then who's the universal recipient? AB, because they don't have any antibodies in their plasma that could potentially react against anything. Now, in terms of the inheritance of the ABO blood types, if you recall, this comes up later, it kind of came up in chapter 29, but it was multiple allele inheritance. That just means that you had 3 choices for each allele instead of just 2 choices. Okay, so for the gene you got from your mom, you had 3 choices, and for the gene you got from your dad, you had 3 choices. You could either get the A allele, you could get the B allele, or you could get the O allele, right? There's still just 1 spot on each chromosome from each parent to fill, but you get 3 things to choose from, essentially. All right. Did that. Structure of hemoglobin. So, how many polypeptide chains is hemoglobin made out of? 4. What's in the middle of each polypeptide chain? Well, a heme group, and then in the middle of that is iron, right? And that's actually the iron that can reversibly bind to the oxygen, when necessary. So 1 hemoglobin molecule can hold a maximum of how many oxygens? 4. And this comes up later in the respiratory chapter, but if all 4 sites are attached to oxygen, then you say what?
100% saturated.
You say it's 100% saturated, right? All right. Remember, the main determinant of hemoglobin saturation is the partial pressure of oxygen in the plasma. How much oxygen is dissolved in the plasma? Because as oxygen builds up in the plasma, it will start to then naturally cross the wall of the red blood cell and start attaching to the binding sites on the hemoglobin, right? And that gives us that whole stupid, and again, this is more respiratory chapter stuff later, but that's what gave us that oxygen hemoglobin dissociation curve, right? All right, last chapter I'm going to cover, try to get through this quickly, is the heart chapter. Matching category of choices. Increases heart rate, decreases heart rate. That's covered in this next section. So describe the response of stimulation from sympathetic, parasympathetic, vagus nerve, acetylcholine, and norepinephrine. I told you guys that ACH means acetylcholine, right?
Yes.
All right. And NE means norepinephrine. All right. So, some things that, you know what? I'm going to throw some things out. You tell me if it would increase or decrease the heart rate. Sympathetic system, increase. Parasympathetic, decrease. Signaling from the vagus nerve, decrease. All right, the vagus is part of this parasympathetic division, and it would decrease it. Signaling from accelerator nerves, increase. Right? Accelerator nerves are the name for the sympathetic nerves that go to it. The neurotransmitter acetylcholine, that slows it down, and that's usually released by the vagus nerve, right? And then the neurotransmitter norepinephrine, that's going to increase, right? That can be released by those accelerator nerves. It can also come from like the adrenal medulla, right? Putting it into the blood during like a fight or flight response. Factors that increase cardiac output. So that's this thing over here. This was the formula for cardiac output. Thank you. So obviously, if you look at this formula, anything that increases either, what's SV stand for? Stroke volume, or HR, what does that stand for? Human resources, that's what I'm going to get busted by. No, HR stands for heart rate. So anything that increases the stroke volume or the heart rate is going to increase your cardiac output, right? So you then kind of have to delve into these things a little bit further. The preload, if you remember, was how stretched out the heart muscle wall was before it contracted. As the preload goes up, what happens to the stroke volume? Does it go up or does it go down? It also goes up. So there's a direct relationship between preload and stroke volume. As this goes up, and if that goes up, that means your cardiac output's going to go up. So increasing preload can increase the cardiac output. What about afterload? If afterload goes up, what happens to the stroke volume? It goes down. It's an inverse relationship, right? Afterload is like the pressures that are on the other side of the semilunar valves that the heart has to overcome in order to open up those valves. So this is essentially a bad guy. So as afterload goes up, it makes it harder for the heart to squeeze its blood out, and the stroke volume goes down, which then means the cardiac output would go down. And then what about contractility? What does that refer to? Just means sort of how forcefully the heart is squeezing. So the more forceful or the higher the contractility, the higher the stroke volume, and the higher the cardiac output would be. The other part of the equation is the heart rate. And we just I just literally covered this. Which division of the autonomic nervous system increases heart rate? Sympathetic, right? So sympathetic stimulation would increase the heart rate, which would then increase the cardiac output. And then there's various chemicals that could have an impact on the heart rate. You know, epinephrine, norepinephrine are going to increase the heart rate, whereas acetylcholine decreases the heart rate. You also have other like medications that patients can sometimes be given called positive chronotropic agents or negative chronotropic agents. Positive chronotropic agents increase the heart rate, negative chronotropic agents decrease the heart rate. All right, sequence blood through the valves of the heart. So let's suppose you're in the right atrium. What would be the next valve that you would go through? Tricuspid valve, also called the right AV valve. Then you're in the right ventricle. What valve are you going to go through to get up to the lungs? You go through the pulmonary valve, also called the right semilunar valve. You go up through the pulmonary trunk, go to the pulmonary arteries, you go to the lungs, you pick up oxygen, you take the pulmonary veins back, you're dumped into the left atrium, and then what valve do you go through? Bicuspid, also called the mitral, also called the left AV valve. Then you're in the left ventricle, and you go out through the aortic valve, also called the left semilunar valve. Okay. Now, that's not going to happen if you're in the fetal heart, right? What were the two ways in the fetal heart that you can bypass the lungs? Don't all answer at once. What's the hole in the wall between the atria called? What'd you say? You're right. The foraminal valley. The foraminal valley is the hole between the right atrium and the left atrium. Yep, that's good. But there was also one more that also lets you to bypass it. It connected the pulmonary trunk with the arch of the aorta. It was called the ductus of it's called the ductus
arteriosus.
That's it, more or less. Yeah, ductus arteriosus.
Yeah.
Yep, good. Okay, good. Oh, sorry. Back to that formula with cardiac output, stroke volume, and heart rate. Again, what's the definition of the stroke volume? It's the amount of blood that is what? Don't all answer once. Squeezed out with each beat, right? Whereas the cardiac output is the amount of blood that's squeezed out each minute, right? So that's why you got to multiply the stroke volume by the heart rate to figure out the cardiac output. So stroke volume, how much blood is squeezed out with each beat? By the way, when the heart squeezes, when the ventricles squeeze blood out, do they completely empty themselves? No. What's the name of that little bit of blood that sticks around? It's called, what'd you say? Residual volume, right? It was called the residual volume. All right, sorry, I just wanted to point that out before I go on. Path conduction system of the heart. So first of all, the heart has, what's that property called where the heart can generate its own electrical signals? Autorhythmicity. And where in the heart does the electrical signaling begin then?
AV node.
It begins at the AV node, okay? And that's incorrect. I just was listening to what you were saying. It begins at the SA node. Sorry.
I was so
You almost railroaded me there. I'm like, it's been a long day. It begins at the SA node, which is the sinoatrial node, which is nicknamed the pacemaker of the heart, right? Where after the SA node does the signaling go? It goes to the AV node. It also kind of goes out to the other atria at the same time, so it's kind of going both places. What does the AV node do to the electrical signal that was really important? It slows it down just a little bit so that the ventricles aren't contracting while the atria are still contracting, right? Where do you go after the AV node? The bundle of His. Then there's two branches, the left and right branch of the bundle of His. And then where was the last place the signal went? The Purkinje fibers, also called the subendocardial branches. Now, do you have nerves connected to the heart? Yes or no? Are there nerves connected to the heart? Yes. We already, right? There's parasympathetic, there's sympathetic. So there's definitely nerves connected to the heart. Do you need those nerves in order to make the heart beat? No. Because of the autorhythmicity, the heart will beat on its own. If, and I don't know if I belabored this point in class or not, but it's definitely on the final, so I want to point it out. If you were to cut all the nerves to the heart, the sympathetic, the parasympathetic, and just allowed the heart to beat on its own, it would increase to a rate of about 100 beats per minute, which is the natural rate that's set by the SA node. So normal people have a resting heart rate that's below 100. If you suddenly cut all the nerves going to the heart and just allowed the heart to work on its own, it would assume the natural rate of the SA node, which is about 100 beats per minute. Okay. What area of the brain regulates the heart? The medulla, right? The cardiovascular center is located in the medulla. All right, nice. That's where we'll stop for today. We'll pick this up on Thursday, and then we'll also do the fun activity.
I did it.